Hi, good afternoon. This is Chem 102, and our topic for this afternoon is about band-like structure. So, what is band-like structure? Band-like structure are formula skeletal structures as a representation of molecular structure in which covalent bonds are represented with one line of each level of bonds order. So later we'll be discovering what makes the difference between bond line structure and molecular structure of a formula. So we have an example here. I'll be using propanol. Propanol is C3. Okay. I'm using different color. That's H8. Okay, I'm sorry for the mish. Okay, uh, H that is H8 and O. So this is propanol. Propanol. Okay, so we have 3 molecules of carbon, 8 molecules of hydrogen, and 1 molecule of oxygen. So remember last time, if we're going to draw the Lewis dot structure for propanol, it will like this. Okay, so we have C here. Okay, C, because that's 3 carbon. Okay, and then we'll connect the valence electron to make it covalent bond, and we have here the hydrogen and the hydrogen here. Okay, and another hydrogen here. Okay, so in the center we have oxygen and we have hydrogen. Okay, so as we notice that oxygen belongs to group 6, so there are free valence electron. Okay, so I label this as 4 dots. Okay, that's 4 dots. And then we have another carbon here, we have another hydrogen here. Okay, so we have another carbon here. Okay, so we have hydrogen here, hydrogen here. Okay, and another hydrogen here. So if we're going to inspect, let's check. We have 3 molecules of carbon and should be 8 molecules of hydrogen. That's 1 2 3 4 5 6 7 8, and we have 1 for oxygen. So this is what we call the Lewis. Okay, okay, that structure, that structure. Okay, I just abbreviate that it's the Lewis structure for propanol. And then as you notice in the real bonding of electron, it's actually in a zigzag, no, it's zigzag in a way that it represents a non-linear actual bonding of electrons. So if I'm going to draw redraw this Lewis dot structure in other way around, it should be like this. Okay, so C, I have C here, I have C here, I have C here. This is my carbon, and this is the that okay, okay, this is it. Okay, and then if we notice this carbon here, this here. Okay, this carbon here. Okay, this is it. So it has 3 hydrogen attached to it. Okay, so okay, so we have 3 hydrogen attached to it. Okay, so that's I'm going to draw. Okay, so that's the hydrogen. So in the other side here there are also 3 hydrogen. So if I'm going to uh, redraw that one, so it's something like this one. Okay, so hydrogen here, have hydrogen here, and this remaining hydrogen here. Okay, and this remaining hydrogen has this one. Okay, and this one. This is it. Okay, so we have here another hydrogen, and we have oxygen and hydrogen. Okay, so remember last time we're going to inspect the octet role for carbon because it belongs to group 4. It should go in 4 valence electrons. So 1, 2, 3, 4 shared by hydrogen, and the 3 shared by hydrogen, and the other one shared by carbon at the center. And if we're going to inspect this one, it has also 4 valence electron. The one valence electron is shared by carbon at the center, and the remaining valence electron of carbon is shared to 3 hydrogen on the right side of this Lewis structure. And same with the other one, the 2 valence electron for carbon at the center is shared with another carbon, the third carbon, and then hydrogen, oxygen. And if you notice, since the oxygens only share 1 valence electron, it has remaining uh, 4 valence electron for oxygen because it belongs to group 5. And that's it. Okay, so what we do now is we will draw the bond line structure for this propanol. So how we're going to do that? Okay, so uh, if you notice, uh, we will omit the hydrogen. Okay, first step is we will omit the hydrogen. So if I'm going to write that one, and I'll omit the hydrogen, hydrogen directly attached to carbon, what would be the remaining structure would be like this one. Okay, so we have carbon here, the first carbon, the center carbon, and the other carbon. Okay, so I'll be going the covalent bond. I'll draw the covalent bond on that, and this carbon is sharing to oxygen. Okay, we have the other valence electron and hydrogen. Okay, so okay, so next we can simplify this further to take out carbon, no? So we'll take out carbon. Here is we take oxygen, and here, and the next step is we will take that carbon. Okay, so we'll take that carbon, and the structure will be like this one. Okay, so the structure will be like this one. Okay, and of course now we have to label the oxygen and its remaining 4 valence electron, and the carbon and the hydrogen attached to oxygen. So by this information, by this information, actually we can still would get, this is our final bond line structure for propanol. Okay, so this is the bond line structure of propanol. So if I'm going to expand this further, okay, so if I'm going to expand this further to basically check the Lewis dot structure of this band like structure, is basically here. Okay, so I'll give you that there's a carbon here. Okay, we have also a carbon here, and then yep, this is a carbon here. So if I'm going to further expand that one to the Lewis dot structure, basically if we have a carbon here and a carbon here and carbon here. Okay, so we know that carbon has 4 valence electron, and the other one is shared to carbon the center. So basically I have 3 hydrogen attached. So if I'm going to further expand that one, okay, so this is it. And same with the other one, if I'm going to furtherly expand that one, okay, I have 3 hydrogen because one of the valence electron of that carbon is shared to carbon at the center, another carbon in the center. In here, if I'm going to expand that one, as I know that this carbon at the center here, if I'm going to highlight this carbon here, the valence electron, the 3 valence electron, are already shared by the 2 carbons and oxygen. So if I'm going to inspect or expect, I have one hydrogen here, so I have one hydrogen here. So you notice that this based on the simplified bond line structure of propanol, I can basically expand it to the Lewis dot structure. So if I'm going to uh, if I'm going to if I'm going to highlight this one, okay, so basically this would be the similar to this. So what I'm discussing today is the bond line structure. Okay, so if you notice in the previous meeting we've tackled a lot. First is we do the dot line structure, that um, the Lewis dot structure. We construct the Lewis dot structure, and when we construct partially condensed and condensed structure, no, and then we distinguish what is the difference between molecular formula and condensed structure. Here another concept, the another concept that we've discussed is what we call band-like structure. Band-like structure is a simplification of that structure for some complex molecule. So that's it. And again, thank you for listening. I hope you get the point. You get what I mean here. And good luck to your homework. That's homework number, I think homework number 4 under this topic, band line structure. Thank you.